Hey guys, I sure do miss you. I decided I would do our math work like I did our study guide so that y'all could watch it and make sure you're getting it right if you want to. So number 1, 3/12 plus 7/12. I'm going to start by drawing I didn't draw it quite big enough. Okay, we know our bottom number tells how many parts in the whole. So if this is the whole, then we know that it should be broken into 12 parts. So I broke it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. Okay, so for 3/12, I'm going to color 3 of them. And then for 7/12, I'm going to color 7 of them. Now, guys, I want you to notice the bottom number stays the same. The whole part is still only broken into 12 pieces. I'm going to add the 3 pieces we colored for 3/12 and the 7 pieces we colored for 7/12, and I'm going to see that I have colored 10/12. And that's the answer to number 1. Okay, number 2, 2/8 plus 4/8. So our bottom number is our total number of pieces. So I drew my whole and broke it into 1, 2, 3, 4, 5, 6, 7, 8 pieces, which is the bottom number. Okay, so for 2/8, I'm going to color 2 of those, because that would be 2/8. And then for 4/8, I'm going to color 4. 1, 2, 3, 4. Okay, so 2/8 plus 4/8 equals 6/8. Okay, number 3, 5/10 plus 4/10. So I drew my rectangle and broke it into 10 pieces because 10 is my bottom number. So for 5/10, I'm going to color 1, 2, 3, 4, 5. Remember, our pieces really should be equal, but Miss Ledlow kind of did some a little bit smaller. We're going to pretend they're all the same. Okay, then for 4/10, we're going to color 4. 1, 2, 3, 4. So when we count how many we colored, 1, 2, 3, 4, 5, 6, 7, 8, 9, we see that we've colored 9 out of 10. Okay, number 4, 1/5 plus 3/5. So I broke my rectangle into 5 pieces because my bottom number, my denominator, is 5. So I know the whole thing is broken into 5 pieces. So then for 1/5, I'm going to shade just one of the pieces because that's 1/5. And then for 3/5, I'll shade 3 of the pieces. 1, 2, 3, because that's 3/5. When I put those together, I see that I have shaded 4/5. Okay, number 5 is 1/4 plus 1/4. So 1/4 plus 1/4 equals 2/4. And we also know that that is the same as, if I just broke this in half, 1/2. Okay, number 6 is 2/6 plus 4/6. So I've broken the whole into 6 pieces. I'm going to color 2/6 And then I'm going to color 4, 6, 1, 2, 3, 4. And I noticed that I colored all 6 pieces, and that is the same as 1 whole. Okay, on these questions where we're telling same and different, you may see different things than me, so it doesn't mean my answer is the only right answer, but I am just going to give one answer just to save a little time. But on this one, let's just note first that the denominator, which is the number of total pieces for the blue shaded circle, would be 8, because there are 1, 2, 3, 4, 5, 6, 7, 8 pieces. And then the number of shaded pieces is 6, so that would be the numerator. And then for the purple shaded circle, the denominator would be 4, and the number of shaded pieces would be 3. So we can say, first of all, that 6/8 equals 3/4, and that's because they're the same. What's the same? The same amount is shaded in both circles. Okay? So even though the blue one's broken into 8 pieces and the purple one's broken into 4 pieces, we can see by the coloring and the amount not shaded that it's the same. So if this was a cookie and I was eating the blue shaded cookie and you were eating the purple shaded cookie, we would still be eating the same amount of cookie. Now, what's different is that they are broken into different size pieces, because the blue one is broken into more pieces. And remember, we said the more pieces we break something into, the smaller they get. Okay, now what is the same about 1/5 plus 1/5 plus 1/5 and 3/5? So for me, an easy way to see this is to draw both of them. Okay? Okay. So this first one, I can say 1/5 plus 1/5 plus 1/5. On the second one, I'm going to label 3/5. I can see that they are the same amount is shaded. Now, what's different about them? In the top one, they have written it as a sum of unit fractions. The bottom one is just written as the total fraction. Okay, the last page says, look at Robert's answer and his thinking. So Robert's adding 5/12 plus 6/12, and he gets 11/24. And he says 11 out of 24 colored in squares in all. And then the question says, do you agree or disagree? And circle one. And then it says, explain why you agree or disagree using words or a model. Use the terms denominator, whole, and numerator. So let's start by talking about what we know. We know that the denominator, is how many pieces are in the whole, right? So how many pieces are in the whole? Well, in Robert's problem, 12 pieces are in the whole. So I'm going to draw my model to show 12 pieces. Okay, he did that. He drew his model to show 12 pieces. But what he didn't think about is that when we add fractions, we're not changing the number of pieces in the whole. We're just coloring in the number of pieces in the numerator. Okay, so it should have looked like this. 5/12, 1, 2, 3, 4, 5. And 6/12, 1, 2, 3, 4, 5, 6. Well, when I add those, I get 11/12. Okay, so we didn't have to change the number in the denominator. The number in our whole stayed the same. We just added the number of pieces that we colored. So 5/12 plus 6/12 is 11/12. So let's look at the questions now that we've worked it out. Do you agree or disagree? Well, I would definitely disagree, because while he got the numerator correct, he added the 12 plus 12, so he changed the number of pieces in the whole. Okay, explain why you agree or disagree using words or a model. Use the terms denominator, whole, and numerator. Okay, so we can simply say we need to add the numerators but the denominator, or how many pieces in the whole should stay the same. And that's how you would answer that question.